fancy name for going left to right is phase shift. This means moving it left to right. And that's a specific translation. We call that a phase shift, and the way that you do that is by adding or subtracting on the inside. Okay, so when you add or subtract on the inside, this is what makes it move left or right. And I do want to connect this one, so let's see if, for a quick review anyway, because the end of the year is pretty much here. So x squared would have looked like this, right? Yes? Because all the things that I'm trying to show you, we've basically done. We've done it mostly with squares so far. How do I make this go left or right? What kind of equation do I need? I just want to make it move left or right. So, right? So like this. But if I do x plus 2 and then square it, which way did it move? It moved left, right? It moved left, correct? It goes the other way than you would think it does. Because really what you're doing here is sort of thinking about, well, when would x plus 2 be equal to 0? When x is? -2. So that's a shift left to right. Well, that's the same thing here. Do you notice how the negative power of 2 that's connected to the x is on the inside of the sign? And that's why this is a left to right move. Okay, so what happened here? Which way did it go? If it says a negative power of 2, then this should probably to the right by how much? Okay, and that's really all that. I mean, you can look at these, and I'm going to try to keep it relatively straightforward. So on the ones that we have, you can probably see that. Now, I'm going to show you sort of algebraically what this looks like. Okay, because if we have to continue with this, and at some point next year, if you're in pre-cal, you would, it would be good if you sort of see the whole picture. So the idea here is that I still want the function to take on all the values for one complete period. So I would like to start with 0, right? The normal sign starts at 0 and ends at 2 pi. Is that right? Okay. Well, that's why you set this inequality up the way that you do. So this inequality would be with the 0 here. This is normal start and finish. The normal start and finish would be at 0 and at 2 pi. So what do you need to do? Well, you literally solve that thing. So let me solve it over here. And you guys already told me what's going to happen here. So x minus power over 2, you need to do what?
Make x 5.
How do you make the negative power over 2 disappear? You need to?
Make x 5
Plus pi over 2? Yes? But then you have to do that here. So 2 pi is what? 4 pi over 2? Yes? So it's going to end at 5 pi over 2, because we're adding pi over 2 to 4 pi over 2. And on the other side, that's a little easier, right? Because if you add pi over 2 here, you just get pi over 2. And you guys already told me that. It went right, pi over 2. So there's your new starting point. Your new starting point would be pi over 2. Okay.
So you solve it for
Yeah, I would do the phase shift first. And then the next step would be to find your period, although it doesn't really matter for us. So the period here is still going to be what? Yeah, it's 2 pi. It would be 2 pi divided by 1, right? What's the number in front of the x on the inside? It's a 1. So do you see that the period is still 2 pi? How else could you have found out that the period is 2 pi? If this is your start and that's your finish, then the period would be, yeah, 5. Well, not wherever it finishes. The period is the subtraction between those two. Remember I said yesterday I should have subtracted. I said I should do 2 pi minus 0. And 5 pi minus pi over 2 is 4 pi over 2, and 4 pi over 2 is? Okay, so the period is the difference between finish and start. Okay? So if you start at pi over 2, then you should end up at 5 pi over 2. Now, why do you think I still find the period, even though I sort of already know it? I'm more interested in the count bys. I need to count by pi over 2 on this one still. Okay? So 1 pi over 2 plus pi over 2 is? 2 pi over 2, which is pi. And then I get 3 pi over 2, and then I would get 4 pi over 2, which is 2 pi. So that's my top line. This next line here, I'm only have this in here once, I think, because hopefully I edited the notes. I just wanted you to see why we did this. Okay, what happens if I plug in pi over 2 for x? Pi over 2 minus pi over 2 is? Pi minus pi over 2 is? Pi over 2, right? 3 pi over 2 minus 1 pi over 2 is? Pi. 2 pi over 2 minus 1 pi over 2 is? And 5 pi over 2 minus pi over 2 is? 2 pi. Isn't this the normal start to finish for the sign? Okay, well that's what we're after. Except because you set up the table to do that, I usually don't put this in my table. It's just a waste of time in terms of, you know what? That's the whole reason you do this, right? So that you have that up there. And that's the whole reason you figure out what you count by, so that you don't have to do that work again. Okay, then what's the pattern for the sign?
The pattern?
Yeah.
What we count by?
No. The normal pattern.
0, 1, 0.
Okay, and I think I said yesterday, you should always have this in the table, right? Always. I don't care if we're changing the period, if you're shifting it left, right, it doesn't really matter. It should be in your table. Okay, in terms of your graphs, what happens then? Well, if you start at pi over 2, then just put a tick mark there. That's my start, pi over 2. How many steps? 1, 2, 3, 4. So 5 pi over 2 is where it finishes. And it starts at 0. I go up to? Down to? Back to? And what did I miss? 0, 1. I missed this one. Yeah. So I'm ahead in my head again. Alright, normal pattern, normal sign.
Those 5 tick marks? Like 1, 2, 3, 4, 5?
1, 2, 3, 4, 5. So yes, because we sort of do 1 point double, right? Start and finish are supposed to be in the same spot.
So you don't start at 0?
No, not on this one. Remember we lined up the table so that it started at pi over 2? Okay? Alright, because you're so close though to the y-axis here, where should this go? The next dot to the left should be where? Not at 0. Shouldn't it be at -1?
Oh, yeah.
So because it's right there, we often would do this. You would make it go through a -1. Because that's just pattern, right? Okay? In front of the 0 is always a -1. Okay, if you ended at 0, that means that the point previously was a -1. So if this one is your 0, then that's the -1. Okay. And I didn't want to end over here either, so let me put a little. You don't have to, so this one was optional. This one over here is optional. Sometimes I don't draw it at all because the count by doesn't look real nice. Like what if you started at pi over 3 and you were counting by pi over 5s? You're never going to get to 0. Pi over 3 minus pi over 5 is not 0. Pi over 3 minus 2 pi over 5 is not 0 either. So it just doesn't work. Okay. Alright. So here's a quick review from, I'm checking to see what we're doing after this. So here's the one that you guys get this a little bit confused with, and this is a normal sine of x. So this is why I said give me another day at least, because I will go through this. This is what we did yesterday basically. Except, okay? Alright, so the period here would be what? 2 pi divided by 4, which is pi over 2. You multiply by, so it becomes, you count by pi over 8. Did I shift it left or right? Nope. So start at 0, 1 pi over 8. I actually have enough room today to do this, so that's 2 pi over 8, so usually that's written as pi over 4. 3 pi over 8, which does not reduce, and then 4 pi over 8, but 4 pi over 8 is actually pi over 2. Okay? So use your period and your count bys to get numbers. So the ones that I don't really need would be the non-reduced versions. And then it's the sign again, so the pattern is what?
0, 1, 0, 0.
Okay? And the 2 does what? It adds, right? So this 2 is add 2 to everything. 2, 3, 2, 1, 2. So what I'm not doing this year would be, I'm not going to make you and have a phase shift and a changing period. So if there's anything going on the inside, okay, it would either be a change in period or a phase shift, not both. When you do both, it sort of gets a little more messy again. Alright, so this one, I started at 0, right? Let me find my marker. So start at 0. No, I need to graph the bottom one. Start at 2, sorry. So at 0 it's worth 2, then it's worth 3, then we're back at 2, we go down to 1, up to 2. Yeah? Oh, because I made a copy mistake. You meant that need to be a 4, right? Yes. Should fix that. Okay. We're good with that one?
Yes.
Well, so you feel better if you were here yesterday? Does that make more sense now? So you've seen a couple more? Alright, so general guidelines. So this would be for all of them. Okay, so what do? Well, in this case, since we have a phase shift, you need to deal with that first. Okay, a multiplication on the outside. So a phase shift here would be the, I'll list them behind over here. So the phase shift is the part where it says sine of x plus pi. So that's your phase shift. The change in amplitude is the 2 times the sine of x plus pi. Okay, so the 2 is an amplitude change. A vertical shift would be either adding or subtracting on the outside. So if I have a negative 1 plus 2 sine of x plus pi, then the vertical shift is this one. So in this case, we're going to go up or down when it says negative 1. It's down, right? Yeah? The negative one's not multiplying, so it's not a flip.
Oh, wait, no.
Yeah, it's just down. Okay, start with your phase shift. So this is how I set it up in my mind. Where do I want the sign to start? Well, usually it starts at 0, and it ends at, it ends, yeah, I'm talking about the x's now. So you're right, if I had asked the question better. Okay, and then I put in, what do I actually have inside this sign? Well, it says x plus pi. So how do you get rid of the positive pi? Okay, so subtract pi on both sides. So this was the start, right? Where do I start? Well, I wanted to start at 0, but that means I need to start at a negative pi. And then where do you end? Right, so that last number is your finish. Okay, so the table is going to start at a negative pi and run all the way to pi. Find the period and what you count by. Let's see. For the period,
Will your period be fine?
no, because it's still 1 times x, isn't it?
Yeah.
Okay, so what do you divide 2 pi by? 2 pi divided by 1, the number in front of the x, and 2 pi divided by 1 is? Okay? If that's a little confusing because you're looking at this pi, how can the period be 2 pi? Where do you start? Negative pi. So from a negative pi to pi is how many units? Right, it's pi minus a negative pi, it would be 2 pi. So the period does come out of that difference again. But And this is why I picked pi on this one, because that makes it weird. Okay? What do you count by? Well, figure it out by multiplying by 1 over 4. We're still counting by pi over 2's. Alright, step 3 is make a table using the values and then find the rest of the transformation after you figured out the 0, 1, 0, negative 1, 0 pattern. So, I have to squeeze it in here. You guys have a little more room, right? Okay, so the table's going to look like this. Where does this one start? And then you add pi over 2. That makes you be at a negative pi over 2. Okay, those of you that are not sure what I did there, I have room here. So I'm at a negative pi, and I need to add pi over 2 to that, right? So that's a negative 2 pi over 2 plus 1 pi over 2. So make a common denominator, and now you can just add in the top only, because you know it's always supposed to be over 2. So what's a negative 2 plus 1? Negative 1 pi over 2. Okay, now I'm at a negative 1 pi over 2. And a negative 1 plus 1 is? 0 pi over 2. And 0 plus 1 is? So we're at 1 pi over 2. And 1 plus 1 is? It's 2. So 2 pi over 2, which would be pi. Is that what we wanted? Start at a negative pi and end at pi? Okay, well then that's good. Okay, now that allows me to write what for the sign of x plus pi? The pattern, right? Start at 0, up to 1, down to 0, all the way down to negative 1, back up to 0. What does the 2 do? And 0 times 2 is still? So 2, 0, negative 2, and 0. What does the negative 1 do? Subtract, right? So minus 1, 2 minus 1 is 1, 0 minus 1 is minus 1, and negative 2 minus 1 is? And 0 minus 1 is? Negative 1. Alright, so I need to give myself a little more room on the lower side, right? I need more negatives and positives in the y's. Okay, so 0 is smack in the middle, isn't it? So I'm going to put 2 marks to the left and 2 marks to the right. And it starts at a negative pi and it goes to pi, so I'll label those. And then you can start at a negative 1. Yes? And I go up to 1, back down to negative 1, down to a negative 3, and then up to a negative 1 again. And so it looks like this. Oh, it slipped. Darn it. Okay, I'm trying to make the line look nicer. Okay. And that would be it.